All right. So, hey, everybody. My name is Aaron. This is Aaron's Audio Corner. And today I am having a chat with Mr. Greg Timbers. Greg, it's your turn, man. Now you get to tell us all about yourself and how awesome you are and all that cool stuff. So, your background, I think a lot of people know, but for those who don't know, if you don't mind, give us a quick spiel.
Okay, well, I was awesome, but now I'm retired, so I'm not anymore.
Doesn't that make you
Um,
more awesome?
no, I don't think so. No.
Oh,
Well,
okay. All
I'm more
right.
awesome in the houseboat venue, but
Yeah.
not so much with speakers.
Oh,
So
okay. Okay.
I came from UCLA, straight out of UCLA to JBL in 1972, something like that, and I got to work with and study under Ed May, who is and always was a major speaker dude, and did most of the really great stuff out of JBL from mid '70s back to the early '60s kind of thing. So I was very fortunate with that. And then I just hung around for the next 43 years and kind of did a lot of stuff. I've done transducer work and I've done system work, and they kept trying to make me management, and I kept saying, "Don't screw up a good thing. That's not what I do." And I was fortunate that they allowed that, because normally when you're offered to move up, you're supposed to take it.
hmm
But they more or less let me alone for a very long time, and I'm kind of good at what I do for whatever
hmm
reason. And they saw it, and I saw it, and it all worked out great.
Yeah. Well, you've got a lot of gems that are tied to your name. And honestly, I was actually going back today and looking to see, things I could ask you about. And the one thing that I want to ask you about is the Everest speaker. Do you have a pair of those in your home by any chance?
No, I
Okay.
I did.
Okay.
It was the first, well, other than before I was with JBL, my first JBL system was some L99s. I worked at a hi-fi store while I was in college, and I got some L99s first. And then just before I left the store and started at JBL, I got some S7Rs.
hmm
But since then, everything I've had at home has been a black box custom, something that I've wanted to do.
Right.
Um, And I did, in fact, get a pair of Everest in 2006 ish. And I had them for a while and then promptly started modifying them because I can't help myself. It's a
Right.
DNA flaw, I believe.
Yeah.
Um, and it got to the point where the enclosure limited me and I couldn't get any further.
hmm
So I took the components out and made my own, built my own horn and my own enclosure and such. So, and that's what I currently have. So
Okay.
it's Everest componentry, but in different enclosures.
Well,
I
I had
don't
seen.
I don't know if this will work. Uh, 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 uh,
Oh,
there it is.
wow. That's different.
Oh yeah,
Yeah. So
yeah.
why are
It
they
kind of takes on some
asymmetrical?
of the characteristics of an L250, um, but it was a special horn design one that I'd never, kind of a hybrid of three different technologies.
Uh-huh.
Because everything has a side effect, and I minimize most of the side effects by blending a little from this, a little from that, a little from the next thing.
Yeah. Well, I like that you mentioned that everything has a side effect because and part of my reviews, I started off thinking that this is going to be the perfect speaker. This is what everybody shoots for. And then the more I started reviewing stuff, number one, I realized that people don't like to be told that their stuff maybe isn't that great. But the other thing is that there is no perfect speaker, right? Like
That's correct.
everything
They're not
is
even
a set
close.
of compromises.
Yeah, they're
Right.
not even close.
Yeah.
So you choose your poisons, and if perfect sound is somewhere in the middle of a circle, everybody's on the circumference, coming from all sorts of different angles, trying to get to that center point. And you can be
Right.
equal distance from the center point and not sound anything at all alike.
Yeah. Right.
Um, yeah,
Well,
life's
but
a
I think
bitch and
that's
then you die. It's very simple.
yeah. No, yeah. I mean, and I think that's the cool thing about, the hobby is that you can starting from DIY to professionals such as yourself, there's all different ways that you go about designing a speaker, and there's different factors involved, sound, the spousal approval factor being one, just the overall aesthetic for yourself, size, those kind of things. So I think it's neat that when you start talking about when you accept that speakers aren't perfect, then you're able to have a little bit more room, I think, right? Like when you don't constrain yourself to this boxed idea that everything has to do X, Y, or Z, then you open yourself up to more freedom to do what you want to
Absolutely.
do.
Yeah,
Yeah,
absolutely.
yeah. And I
And
just think
that's
that's
one
kind
of
of
the
neat.
things that attracted me to your reviews. You were much more open about, um, I mean, yes, measurements are good and blah, 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 but to my ear, this is this way or maybe this way, but other people might see it differently. And I
Right,
appreciate that approach as opposed to the really solid reviewers that, well, this is what it is, and there are no other opinions. That just isn't true in my opinion.
right. Yeah, I agree. I mean, I think that I certainly believe in measurements. Otherwise, I wouldn't be doing what I'm doing. But I think the measurements go more towards serving, helping people understand what it is they like or do not like about a speaker. And you can't get that right away. Like you can't just drop somebody into a chair and say, "Here's a measurement. Now you know what you like." I think you kind of have to build that compass, right? You have to steer it in the right direction. Maybe listen to a few different things, look at some measurements, and try to help you refine. But even then, I don't know that everything is going to be captured by the measurements that we're
It
doing
isn't. It
to
isn't.
date.
We
Yeah,
still hear a lot of things that I I can't measure. I don't know how to measure. I don't believe in magic, so there must be
right,
some way of doing it. But some of this imaging stuff and the difference in digital signals and the like, which on paper shouldn't exist, but they do, um, just don't just means we don't know how to figure it out yet. Doesn't mean it's not real.
right. Well, I think that's another example of speakers. We understand radiation, polar patterns, and things like that. We just the the general community. We're starting to have more
Yes.
data available to us. So we're starting to be able to reconcile those kind of things. But there are some speakers sometimes where I'll listen and I'll say, I heard, this sense of depth in this speaker. Now it may be totally my brain, but let's pretend that it's not. How do I put that into terms of data? And that's one thing that I just don't know. Is it a time-based function? Is it the vertical versus the horizontal? And that's just something that I don't know, but I think that's worthwhile to continue putting the data out there because hopefully at some point somebody else will come along and they'll see this collection of data and they'll say, "All right, now I can start trying to figure these things out too." So,
Yeah, it's all moving in that general direction, but it's not going to happen soon. It's.
yeah,
I mean, it's been a lot of years since speakers have been essentially the same. Um, I mean, you can go
right,
back to the 20s and the Western Electric compression driver is essentially the same device as what JBL currently produces. There's been material improvements and things of that sort, but it's not night and day kind of differences.
hmm
And a cone driver is a cone driver. They're kind of the same. You can do better job or a worse job, but they're still kind of the same.
hmm
And that's sort of where it's at. There's some other specialty things, electrostatics and planers and the like, which do what they do, but none of them are exactly correct, and none of them are perfect. And it's scary how little we've evolved in all these years compared to some other industries. Um, it sounds a tough one.
hmm
It's really difficult. Most
But it's
anything that
fun.
generates a sound that you listen to is massive compared to the speakers. Maybe not a single instrument, but even a piano is huge compared to a speaker. So how are you supposed to reproduce all the nuances that come off of every part of that massive wood structure out of
Right.
a couple of little toys? It's
Yeah.
scary. And
Yeah.
we won't talk
Well,
orchestras.
but I think it's cool that the measurements are kind of helping to serve the improvement. But also at the same time, it's interesting to see how the technology is getting smaller. Now we're packing a lot more into smaller speakers, and you can get a pretty decent set of little bookshelf speakers for about 150 bucks today, whereas 5 or 6 years ago you probably couldn't get that. And I think that's kind of cool to see, and it's
It
getting
is.
people, I think, maybe more into it. You know?
My management was always, well, hey, a TV used to cost, I don't know, make up a number, $1,000 for a color TV, and now you can get a panel that's 10 times better in every respect for 299.50. Why can't you guys do that with speakers? And I go, well, yeah, it's not quite that simple.
Right.
But you are right. You can get some very nice low cost speakers that are quite presentable. And multi-channel is helping a lot,
Yeah.
because you can get by with five of these little guys and generate a very nice sound field, whereas trying to do the same thing out of two speakers requires a lot more heroics.
Yeah. But so, do you have a multi-channel system, or are you a pure stereo?
Oh no, I'm multi-channel.
Okay. Well, I saw the big projector. Is that a JVC above you?
Yeah, that's a JVC, and
You got the good
back
stuff.
there in the corner is K2.
Oh man, you got a nice setup.
And
I mean,
then
you should
without
have a
hurting,
nice
I
setup.
don't know, did that show? Can you see a ceiling speaker up there?
I see a cutout for one. Yes.
Yeah, so that's also that's a really cool product. It's a JBL Pro product that has a little miniature compression driver and a super shallow horn. And you can either get it with, I think, a single eight or two fives. I got the two five, the double five version.
Huh.
But because of the compression driver and the horn, we were able to set the pattern exactly the way we wanted, and the thing's dynamic as hell, which is what most little ceiling speakers aren't.
Right.
So you can litter these puppies around the room and then have something massive in the front, and as long as you cross them over at 80 or 100, something like that, you can get really, really good quality sound out of them.
So, are you running Atmos or Oro or what? I mean, or
I've Atmos. Um,
okay.
it My system is very convoluted. It's primarily designed around stereo,
Mm-hmm.
um, but because I haven't run across a processor or a receiver that has the sound quality I like for just two channel. So
Right.
what I do is, I've got the front channels all set up with all the bass and everything, because I don't have a subwoofer per se.
Mm-hmm.
Um, and then when I go to multi-channel, I use my receiver. It happens to be a Marantz thing, 8805 or something like
Oh
that.
yeah. Yeah.
Um, and the front outputs, I just run into the uh, input of the front speakers.
Yeah.
So as far as the Marantz is concerned, it's just another electronic powered speaker. It doesn't know the difference. And then the other
Right.
stuff goes to the other speakers all over the room. And you
Mm-hmm.
set all the time delay correct. And again, the Marantz doesn't know the difference. My front channels have to go through another piece of electronics, i.e., the Marantz. So I'm not quite as good, but it's still really, really good.
Yeah, I bet.
Um,
What? So, what are you run? You're running a full active setup, I take it, on your front channels,
yeah, I'm full
a
active in
DSP.
back. I made the K2s are active as well,
Oh, okay. Man, that's
and
pretty sweet.
I didn't bother with the little ceiling guys. They're not that big a deal.
Right.
So yeah, I'm pretty much active, and I'm using a DEQX, which is a, electronic crossover slash preamp out of
Right.
Australia,
Yeah.
and
Is that a Behringer? Right.
it can do linear phase. So I'm doing what, a 48 dB, yeah, 48 dB per octave linear phase crossovers.
Mm-hmm.
And I did that in the K2s in the back as well. Um, and it's very nice.
Yeah. I bet. So, I think this is maybe a perfect segue into many of the questions that when I polled my patrons, what would you like me to ask Greg? A couple of them at least were in the vein of what was your process when you were designing a speaker? You know, how were measurements involved? How was ear listening involved? And I'm sure you had a good variety of both. So, well, I guess that's the question. Really, is what was your process when it came time to design a speaker? And I'm sure it's convoluted, but I'm curious.
Yeah, a little. Generally, we have to, we at JBL. This is how it was done there. I don't know. It's the same everywhere. Um, Marketing would decide. Well, we want one of these, and we want it in green, and we want it to do this, and it should have a snorkel and a tail and web feet and whatever was whatever's appropriate.
Right.
And this is how much it needs to cost, which is always too little. Um, so then we would select transducers that we had in the old days. We'd select transducers that we had that we thought were appropriate, and if we didn't have anything, we'd set about designing or altering an existing design to meet what we thought the criteria were. And then you have a meeting or two and run that past everybody, and they say, yeah, okay, that looks good, let's go. So then obviously make all kinds of measurements on the woofer and the mid-range and the tweeter or whatever number of devices it is. um, we have an industrial designer come in very early in the program, and he's told it's a 15-inch two-way, or it's a 5-inch two-way, or a something inch three-way, or a horn, or whatever it is. And he comes up with a bunch of industrial design sketches, and then we all sit around and look at them and say, "Oh, this looks really cool. This looks really cool. Oh shit, I don't even know how to build that." Which was the Everest. They said, "Oh, that's gorgeous, but I don't even know how to make that." Um, and then there's some arm wrestling at the table and some kicking underneath the table and things of that sort, and kind of come out with a direction, because the enclosure is integral to the whole design. The way it looks and how it goes together is part of the package. It's every bit as important as anything else. So you
Right.
kind of have to have that data at the outset.
Hmm.
And then once that's the case, we went to the model shop and said, "This is what we'd like. Make me a couple of these, and load transducers in them." And um, now, in the older days, before all this computer aided stuff, you just sort of had to try try things and make measurements, and try things and make measurements. Later on, it got to the point where you could put all the transducers in the enclosure, and you go in the chamber and measure the individual transducers in their boxes. And now you've got that information,
Right.
and then either with one of the variety of program Leap, or one of those programs that are around, or however else one would do it, you come
Hmm.
up with some crossover components and put the whole thing together and go, "Oh, that looks pretty nice," or "Oh my God, what did I do?" Which happens a lot. Um, I personally built a what we called a network cart, and it was had a bunch of network components in it, and was capable of doing four-way systems, just knobs, binding posts, and knobs
Yeah.
on wheels, weighed a ton. So I could put my two speakers in the sound, or one speaker, actually, I didn't have enough for two of them. One speaker in the sound room, and dial in the crossover values I wanted,
Hmm.
and listen to it um, live. Now, obviously, there's insertion loss and all kinds of things that aren't going to be there for real, but you can get a good idea. And then I was able to take a real time analyzer and do off axis and move the mic all around the room, and look, oh, look at, there's this weird thing here, or there's this funny thing there.
Hmm.
Um, so I personally was able to get something that um, I like sonically and kind of measurement wise. Then you could take the thing, put it in the chamber, and run the spins and do all that stuff. And more
Yeah.
often than not, most of the issues were taken care of because I saw them in advance. I saw them in advance in the sound room.
Yeah. Yeah.
Um, Most people didn't adopt my technique. They just went to the chamber and iterated over and over and over. You end up I guess, with kind of the same results. But I got pretty good with this cart.
Right.
Um, Later, the programs got so good that you could pretty much predict what was going to happen by looking at off-axis measurements, using the various curves from the spinorama and
Right.
applying the crossover to those curves, and
Right.
you would
Yeah.
be able to reconstruct what the 40-degree line is going to be, or the 30-degree line, or something like that. But that was really a lot later. That's only been in the last 5, 7 years where the software is powerful enough to do all that, because it's a lot of data crunching.
Right. Well, there's a, and I'm sure I'm going to mess the name up, but it's Vitrix CAD. I've never actually tried to say it out loud, but it's VITIUX CAD. And
Okay,
it's
I'm
a
unfamiliar
DIY.
with it.
Yeah, it's a DIY type program that a lot of DIYers use, and that's kind of the method they take. Is they'll, for the most part, a lot of them will go ahead and pick the enclosure. They'll put the speakers in the enclosures. They'll measure each one individually. They'll throw the models into this program, and then they'll model up their crossover and then build it, make sure it checks out, and then they're good. So, and that's come along. And I don't know how long that's been out, but I remember using Leap about 8 years ago on
Oh,
a on
Leap's
an
been
active.
around for a long, long time, but Leap is
Yeah,
both expensive and very, very difficult to use.
Leap. I used to take my laptop with me on work travel, and I would spend hours in the hotel room at night after I got off of work just trying to understand what I was doing to Leap. I didn't have a clue. I was just poking around, and then I would go and measure. Actually, I'd come back
Yeah,
home and I'd be like, okay, I'm gonna try this out, and I'd measure it, and then that was part of the learning process, is correlating. Am I doing the right thing in the program versus what I'm getting in the measurements? But to me, that was really the fun part, and that's where I learned the most. Is a lot of trial and error.
yeah. If you give Leap accurate information, it will give you an absolutely accurate result. The math is brilliant. The programming is brilliant in that thing.
Yeah.
Unfortunately, it was Windows, and they never, or I'm sorry, DOS. They never really got to Windows, and the interface is very difficult.
Yeah,
But
yeah, it was tough for me. It was.
and it only ran up to what, XP. It didn't go to Windows 10, I don't
Yeah,
think.
I think that's right.
I
I think
still
I
have
was.
XP and emulation on my Mac with Leap on it.
So you can use it.
I can still use it. Yes, I can.
Yeah,
It's
that's pretty
it's
funny.
crazy. Yeah, it is.
Yeah. Well, so the speakers that you showed of yours that you've got built, I noticed that they're asymmetric. You've got the
That's
woofer,
correct.
and then it's so why? I'm curious. That's just really I've not seen somebody do that before.
Well, the L250 was that way.
Okay. Well, then I've not seen the L250. I guess
Okay, yeah, that
I'm
was
about to go
from
Google it.
1980. We built those for almost 20 years. The reason is just making the edge of the enclosure asymmetrical for the
Ah,
diffraction, and the baffle width also varies
right,
everywhere. So it
right,
it randomizes reflections. You can't make them
right.
go away easily.
Hmm.
So if you randomize them, they're not as big a deal.
Okay. Yeah, I was wondering if it might be diffraction, but I was thinking with as large as the woofer was, I wasn't sure if it really went down that low in frequency to make a difference there. So
Yeah, the cabinet is so narrow that the woofer would beam before it sees the edges.
okay.
Not so much with the horn, so that helps
Right.
a little. The real reason I went this way is my screen comes down out of the ceiling, and that's all the height I've got. And I
Okay.
needed I needed another couple of inches to really do what I wanted to do.
Yeah.
Um, so by doing the box asymmetrical like that, I was able to skew the woofers and pick up 2 inches in height.
Yeah, that's pretty cool. I was
And
thinking
the bottom
thinking outside
woofer
the box.
doesn't go up high enough, and it's right on the floor, and you get rid of the ground bounce by doing that. And then the other woofer is at a nice height. So it's basically a two-way with an augmented a woofer augmentation.
So would you consider that 2.5 way? Because I've heard that term used to kind of describe like where the bottom woofer rolls off a little bit sooner, than the
Yes, that's a
upper
two
one.
and a half way. Both woofers go all the way down.
Mm-hmm.
The Right now I'm using a first order on the bottom woofer
Mm-hmm.
that starts kind of low, so it just gradually rolls off, and then the upper woofer comes in, goes out to 750, and it's
Oh, okay.
shut off pretty fast. But it's
Yeah.
linear phase, so you don't have the weird lobing and summing business that you have with traditional analog crossovers.
Right. Yeah. Yeah, that's a pretty neat design. I liked it. So, and that's all using the DEQX, right? That's what you said?
Yes. I mean,
Okay.
it could be done
Yeah.
passively, it could be done, but passively, I couldn't linearize the phase.
And I could only
And the
imagine the
other nice thing
cost.
about active is, well, digital active is I can time align everything.
Right. Yeah. And then does it have a all pass on the DEQX? Um, seems I can't remember if it had an all pass, like a variable phase, where you can incrementally adjust the phase rotation of the different channels. It seemed like one of the Behringer units I used to have did that, but I don't remember if it was a DEQX.
The Behringer will do it because it's not linear phase. Yeah, you would use an all pass filter if you were doing analog style crossovers.
Okay.
If and I get my IIR and my what's the other one mixed up.
FIR?
Yeah,
I
yeah.
always
One
mix
of
them
them
up.
is finite impulse and the other is infinite impulse.
Yeah,
One of them is an analog equivalent. So if you screw with the amplitude, you screw with the phase.
the phase. Right,
The linear phase one, you can manipulate phase and amplitude individually
right, which is really
with
cool.
other side effects. But
Yeah.
um, so that one really doesn't need an all pass. That configuration doesn't need all pass
Okay,
because
okay.
the entire roll off slope of either the high pass or the low pass doesn't rotate in phase.
Mhm.
It,
Yeah. Well, and so you're using the DEQX. I'm thinking of maybe the Behringer was a DQX or something like that. But now I
yeah,
remember
yeah,
what you're talking about. You're talking
yeah.
about the DEQX is like the next. It's a nice piece of equipment, right? And I think they're
Yes, it's
actually
a
coming out with a
really
newer one.
yes, they are.
When
I'm really excited about that.
Yeah, it's eight. I think it's 8 channel output on that one as well. But there's a whole bunch of other goodies built into it.
Yes, well, you're up on it. It's yeah, it's a four-way stereo.
Yeah,
So that would be eight channels.
yeah.
Um,
That thing looks awesome.
they've added stereo EQ. This one only does EQ the two channels together.
Hmm.
And they've added a post room EQ function,
Ah,
which um, which combines both just plain EQ and time arrival stuff.
okay.
So I'm very
Yeah,
excited to get my hands on one of those
I'm curious
because
what
I'm
it's going to
currently
cost.
cascading two models to get my four channels.
Yeah, well, the reason I'm aware of it is because I got like an email or something from them maybe like 3 or so months ago. I can't remember now. It seemed like it was earlier this year, and I pulled it up and I was thinking, oh my god, like that's kind of the because most of the stuff that I mess with DSP stuff is like the mini DSP. I don't know if you're familiar with that, but that's a really great piece of machinery, and they're budget friendly. You can get
Uh-huh.
a two-way
Well,
active,
mini
so 4 channel
DSPs
out.
are too. Mini DSPs do a lot of stuff.
Yeah, that's what I'm saying, and they're a lot more budget, but I think they're more limited than the DQX. I'd have to go back and
Well,
look
they
at the
don't
spec of
sound
it.
the same either. The DEQX has some remarkable A to Ds, D to As, and their analog circuitry is state of the art.
Yeah, I've been wanting to email them and ask what the price is going to be just out of curiosity, but I
I
can't
haven't
imagine it's going to be
heard.
cheap.
I haven't heard. These boxes were 5,000 plus or minus, um,
Yeah,
depending on which one you got. I I shouldn't really say it. My gut feeling is it's probably going to be just under 10
yeah,
for the
I
big
wouldn't be
one.
surprised. Yeah,
Yeah,
I actually knew a
that's
guy
my
that.
but I don't know, And then they have 3 models altogether. The second one, I think, is just does a two-way, so it'd be
Mhm.
4 channels. And then their base model is really interesting, and I don't know if it makes sense from a sales standpoint. We'll find out. It's powered. It has a built-in amplifier,
Oh, wow.
and it's intended to be used. It doesn't do crossovers. It's intended to be used on passive loudspeakers.
Interesting.
Their current box can be configured that way as well, and what it does is it goes in, it makes measurements on the loudspeaker near field, and then it goes in and it corrects the response and time base, and that's how they got started doing that. The crossovers were secondary, and you apply their correction to a standard passive loudspeaker, and it doesn't sound like the same speaker anymore.
Interesting.
Because they fix all kinds of well, the EQ is always nice, but they're fixing
Right.
time-based stuff.
Yeah.
They can
Yeah, that sounds
actually, in effect, time align the loudspeaker
like
and take
kind of
out the
individually.
group delay that's in the
Yeah.
passive networks and stuff. Yeah, it's really
Yeah,
impressive.
that's really cool stuff. Yeah, there and that kind of, I mean, I'm not saying it's the same thing, but it reminds me of kind of what Direct Live
Yes, yes,
does.
exactly. Yes.
Yeah. Yeah. And that's just some really, I mean, having experienced Direct Live, even in my car audio system, I was like, wow, this is crazy. And all I did was just drop it in front of my active EQ and then
Right.
just ran it two channel or was, yeah, post or pre active EQ. Ran it two channel. It didn't change any of my other settings. And I swear I heard a difference, like it just sounded,
Well,
everything sounded more
didn't
cohesive.
didn't you have to make a measurement in your car, or does it
I
it
did.
has to know? Yeah,
Yeah, I
okay.
did. Yeah, a multi-point measurement. It says, place the mic here, place the mic there, and all this stuff.
Yeah,
It's
so
a
it's going in and, yeah, it's yes, they are they work. Very
yeah,
convoluted, very difficult, math and everything, and that's what their entry level box is gonna do. It'll have a built-in power amp, so you just connect it to a pair of stereo loudspeakers, and it's a preamp, and, you make the measurements this way a little bit, and, it'll fix all kinds of things that are messed up in the loudspeaker.
right. Yeah, and it's stuff that you don't think about. Like most people can't fix that. So that's why I kind of always preach, if you're going to buy a speaker, buy the best one available for you before you stick it in a room, because once you do that for pretty much everybody, they're not going to be able to fix a bad speaker after that. Like
No,
some stuff
if
in
the
the
transducer
crossover.
isn't capable, it isn't capable.
Right. Yeah. So, well, and that kind of brings me to, I've got a couple other questions, and I don't know how much time you've got today. We can maybe always pick up
Whatever you
again
like,
later.
'cause I'm all relaxed here, it's real easy.
Well, good, man. That's what I'm shooting for here. I just want to pick your brain a lot. Um, let's see here. The challenge of designing a speaker, I think you kind of already touched on that about when you're talking about a budget speaker versus a no holds barred. So I would consider something like the 5 series that you designed and more of a budget minded speaker, whereas
Yes.
something like the Ever speakers are kind of, I don't know how that worked at JBL where they said, look, we want you to build a flagship speaker, unlimited budget. I doubt that happened, but it was certainly more, I would assume, that case than it was with the 5 speaker, where I'm assuming they probably gave you a target to shoot for.
Well, there was a target on the Everest as well, and remember, big
Right.
companies have massive markups for so a
Right.
dollar you spend a dollar in parts cost, and it's 4 or $5 to the user.
Right.
So things can get out of hand, but obviously the Everest was much more flexible than, uh, than the 5 series. Um,
Yeah.
Designing good budget speakers is much more difficult than big speakers, less, um, price sensitive.
Right.
Yes, you're expected to get better sound, but, being really clever and really economical in a small speaker is considerably more challenging. And the 5s turned out really good. Um,
Yeah.
they had no business sounding as good as they did. I was lucky twice. Jerry Morrow was assigned to do the transducer work on those, and he's wonderful. And he did some really nice transducers that we had produced for us, but to our specifications. And then that was the first consumer use of this little toy compression driver that I was talking about in the ceiling speakers that um, a pro engineer, Voice Velo, It's his last name, did this design. It is very unusual in every way, shape, and form. The diaphragm is TNX, which is it's a plastic material, not unlike mylar, but it isn't mylar. Um, and it has some really good acoustic properties. And he made this very tiny little compression driver out of it. So I just did some horns, and um, we were able to get. It was limited into how low it could go. 1800 hertz was as low as it would go, and it just said no. I won't go to 1750. Sorry, don't even ask. Um, and so that means the crossover point was a little bit high, but from that point on, it was just wonderful, and it's super smooth sounding, and it had nice response, and they were reasonably consistent for a cheap driver, and the systems turned out really really good.
Yeah, I don't think I've heard anybody have a bad comment about any of the 5 series that I've seen so far. So, um,
And that one, the industrial design held us back. Um, it's a very inefficient design. If it didn't have the hidden woofer and the funny baffle and the weird shape,
yeah,
I could have had 50% more box volume, or the
yeah,
speaker could have
that's right.
been
Because the woofers
smaller
are,
wide.
yeah,
Yeah, it
they're
blew a lot.
inset some.
I tried. I whined and sniveled, and I got some of it back, but they wouldn't go all the way.
Yeah.
Uh,
Well,
but
like that, and that's the stuff that I wonder about. Just as a regular old dude, I think, how does that work when you want to design something? Like, do you have something in your brain that you're kicking around and you're like, man, we've got to build this, or is that really dictated by, like you said earlier, maybe the marketing department, or is it
production products
depending?
are dictated. However, um, engineers do have ideas, and we had a great model shop guy, and when there was time, you just sketch something up and say, "Would you build this for me?" And he builds it for
Yeah,
you, and then you put together some transducers and cobble something up, and then when you get it, if you get it to where you want it, you bring some marketing folks down and say, "Look at what I did."
yeah,
And 50-50, half the time they throw up on the carpet and then leave. And the other half the time they go, "Oh, can you make that in blue?" I go, "Sure." "Oh,
yeah,
let's look at that."
yeah. That's pretty funny. You get a little bit of spray paint to solve that problem.
Yeah, exactly.
Yeah. So, do you ever want to punch any of those marketing people and say, "Listen here, let me tell you what we're going to do"?
Yeah.
They probably wanted to punch you, though. To be fair.
Well, that's it. We companies that are designed and run purely by engineers invariably fail. And companies that are purely marketeers in either fail or end up just selling snake oil, nothing of value. If you don't have a competent team with really good manufacturing folk and really good marketing folk and really good engineering folk, you're not going to be super successful in the end. Because I don't know how to market stuff. That's not what I do for a living. I don't know how
Mm-hmm.
to make the books balance at the end of the month.
Yeah.
And if you don't have a leader that's a visionary, um, that's able to take input from all these various factions and come up with a valid decision based on that input, you won't be as successful either. So I'm a really big team guy.
Yeah.
I do what I do very well, but I don't do what they do at all. I'm not good at it.
Yeah.
And knowing that and working with people, and eventually you get, if you're lucky, you can get the respect of these various folk and put a good team together, and then upper management will generally then just kind of leave you be. This is what
Yeah.
we want to do, and we're going to go do it. And they say, "Yeah, okay, here's some money, go do it." And that's what worked best for me.
Mm-hmm. So I guess you kind of mentioned the dynamics earlier, and we had one question. Um, say in his interview, which you did an interview in 2017, which I've forgotten the name of the website, and I will do my best to link them because I actually read through it a few times, somewhat recently, and I really there were a lot of things you said you talked about in that interview. I was like, man, that's a question I wanted to ask. So we won't rehash a lot of things, but there in particular is that in his interview he talks a lot about speaker dynamics and how this is very important to him. You how is the term defined scientifically, and is it the same as dynamic compression, and is it something that you can show in measurements? And I think that's a really good question. Is and I'll kind of go on a little bit here, and then I'll
The
let you
answer is
answer.
no.
Yeah, okay. Well, that's the
And
question
that's
because
it's really unfortunate because it is a primary function of a loudspeaker, and there's a real simple test for it, um, or demonstration for it. You're shopping for your Christmas presents, and you're out in this giant mall, and there's people all over the place, and they're talking and there's stuff, and there's piano music coming from the background in the background. Maybe it's upstairs, maybe it's downstairs. You don't know where it is, but it's piano music. You know if it's a live piano or if it's a recorded piano. You can't see
Mhm.
it. You don't know where it's coming from. It isn't power response. It isn't frequency response because those things are all screwed up by the time
Yeah,
they get to you. And yet you can tell, generally speaking, if it's live or if it's Memorex. The same thing's true of a little trio or something of that sort.
right.
Well, the only thing that can do that is dynamics. The only thing that's left. And here it is. You can't see it. You can't feel it. You don't know where the hell it is. And yet you can tell right off the bat if it's, you know, if it's real or not. So
Yeah,
if speakers don't have good dynamics, guess what? They aren't going to pass the real versus Memorex test.
right. Well, and
Um,
there's a lot of people that love that live sound too, and it's like, well, how do you relate something like that with data? I mean, I don't know
yeah,
how to do that.
it's very. I mean, we can make some static compression measurements, and your clip will attempts to do some of that stuff.
Right.
Um, Unfortunately, it most of the machines I've seen that try and measure it aren't quick enough. You have to really put a big crest factor in and make the measurement super fast, um, because that's
Well, I
what
mean,
we're hearing.
that's what
You're just
dynamics
hearing
are.
you're hearing
Yeah,
these little bursts,
it's the
and
instantaneous.
it's so difficult to detect that. And that's one of the things that generally tells a record, a phono from a CD apart, is the records tend to be more dynamic. And how in hell is that possible with, you're in vinyl and you're shaking a little stick with a rock on the end of it? Now, how in the hell is that going to be better or more dynamic than essentially a perfect copy
Right.
digitally? But time and time again, the things come out, they come out more dynamic for whatever reason. And tapes do
Yeah.
too. Tape machines do as well.
Yeah, that's interesting.
So there's something going on, but the measurement of it is just not easy.
Yeah, I mean,
Um,
I don't know how you can relate that. Like you've seen, we've talked about it before. And the only thing I can think to do is take a low level measurement, increase the amplitude, and just see what the changes in response is, and maybe that kind of is a hint at what's going on instantaneous. But
and
I still don't know.
that will work. That will work to give you a baseline. Actually, if you've done that, depends on how long you leave the signal on. But if you do that with passive loudspeakers that are multi-way or even two-way,
Hmm.
um, you'll see the response change as the level goes up.
Yeah.
Um, because at the crossover point, each transducer is more or less 6 dB down, so it's getting quarter power. So it's not heating up in that location. But when the signal gets to its pass band, it's getting 4 times the power. So what happens if you do some of these slow sweeps? Um, the speaker will heat up and compress,
Right.
but less so at each of the crossover points because there isn't the same heat being generated there.
Right.
So now you start to see kind of a ripple in the response of the loudspeaker.
Yeah, and
And
I've seen that in some measurements. Not many, but some.
Yeah, it's real, and you can hear it before you can really see it. I mean,
Yeah.
because it's fairly broadband, so when an effect is over a large area, a tenth or two of a dB is audible. If it's just at one spot, yeah, you can't really tell.
Right. Yeah.
Um, so yeah, and that's something that I used to always check for is rough these things up early on in well, a while back. An engineer came into Harmon that was really hot on Melissa, MLSSA, this
Yeah. Yeah.
measurement system.
Hmm.
And we were using B&K equipment because this was right at the onset of computer stuff and there were all kinds of side effects. Um, and he swore by this Melissa thing and the math was accurate and everything. And sure enough, it gave what looked like a representative curve if you ignored the base problems. If you didn't run it long enough, you didn't get good low end. But all that considered, you got curves. But I could consistently show him, and it took a while to convince him that the sine wave sweep didn't give the same answer as his Melissa did on some loudspeakers. On others, it did.
Hmm.
It turns out that it was the heating effect. So if I would run one of my heroic speakers with a compression driver in it or something like that. And we ran, a 2.83 volt sweep, something of that sort. So kind of 1 wattish.
Hmm.
And you run the sweep and you get a curve. And then you put in some little toy loudspeaker with a little itty bitty tweeter that can't take a whole lot. And you run the Melissa, you get a curve. You run the sine wave and you get a curve with a droopy high end above maybe 10K. And then we would argue back and forth about which one was right, and finally came to the conclusion that, oh, they're both right.
Right.
It turns out that what's happening is the sine wave is stressing this speaker. So if you run a long sine wave curve, you're actually heating it up and it's rolling off. The Melissa
Hmm.
is so fast that it didn't introduce much heat distortion.
Right. Like there's no time for it to heat up.
Yeah, yeah. It's just bam, and it's and it's done.
Yeah.
And it's noise, so it's spread out over the whole area, not the one
Right. Not it's
all
not
1
working its
watt.
way.
Yeah, working
Yeah.
its way up.
Right.
So then we were able to convince ourselves that both are right, but you had to be careful what you're doing or you wouldn't, necessarily get the answer you want.
Right. Well, and that's another case of compromise. Depends on what you're trying to do. So what
Yeah,
you're looking for.
it's measurements are tough. I mean, it's not people think it's real simple. You just measure a loudspeaker. No, it's not that easy. And you probably found that if you can get the same measurement plus or minus say a half dB on a regular basis, you're doing real good.
Yeah. No.
Same exact
100%.
loudspeaker.
Yeah.
It's very hard to do better than that.
Yeah. Especially before I had the Clipple near field scanner and I was doing outdoor measurements, ground plane, gated quasi anechoic off the ground. I mean, that was a
Temperature's gonna
nightmare.
drive you nuts. You have to bring in the barometric pressure, you have to bring in
It
temperature.
was yeah.
If the sun
Yeah.
happens to be shining on a black cone while you're
Yeah.
making a measurement, that damn thing is heating up and it
Yeah.
shows. Yeah,
Yeah.
it's
No, I've run into that with the subwoofer testing when it was really hot outside, and I didn't think about it. The actual the amplifier and the speaker itself maybe heating up, and I was getting some numbers that didn't make sense from a couple weeks before that, and I was like, "Well, what's?" And the only thing that had changed, so I waited for it to cool back down, and then I got numbers that were more in line with the other before. So it's weird.
yeah, it's crazy, isn't it? We
It
we
makes it
had when we did ground planes, we had a tent or an umbrella or something like that, I guess you'd call it.
yeah to keep
That
it cooler.
well, yeah, we just shade the loudspeaker with it.
Yeah, yeah. So here's a question for you. So you're a big fan of compression drivers and horns.
Yes.
I'm curious what your thoughts are because I hear a lot of people, even when I review newer horn type speakers, they'll say, "Oh, well, I don't like horns because they sound like, they have, I don't know, they had this horn sound to them." And
Yeah,
I'm thinking
they're horny
that,
and they
I
bark
mean,
like a dog.
right, but that's like, I think of that as in like PA speakers. Like I know what that sound is like, but hi-fi speakers with horns, good ones as of late, they don't sound like that to me.
That's correct.
Uh, yeah, so I think it's a different design.
It is a
Well,
different
obviously, but
design. It came down to learning um, what's bad about compression drivers. Um, it's one device operating over a very large range, which is difficult.
hmm
The horn technology has changed to the horns now are much shorter and they have very rapid flares. They aren't deep. Um, in the old days when these things were used in theaters, the horns were very very long and had gradual flare rates,
hmm
um, and that gives much better loading. It gives more output. It gives you control down to a lower frequency. All very good things, but it makes the second harmonic rise go crazy, which all compression drivers or all horn systems have.
hmm
And that, in conjunction with crossing the things over too low, even though they had response down there,
yeah.
it just, yeah, they bark
Well,
like
I
a
think
dog.
that's the thing. I mean, and having built a few different horn designs myself, I think, oh well, it can go down to, because I've got a JBL 2446J compression driver. I don't know if you're familiar with the
Yeah, you
model
put
names.
that on a big enough horn, it looks like it'll cross
Oh,
over
it's
at 500 hertz.
yeah, exactly. Well, that's they came from a theater. They actually came from the literal
Yeah.
theater in town, and that's why I bought them, is because I grew up watching movies at that theater, and I'm a nostalgia junkie. And I was like, oh my gosh, I got to get these speakers. So they're in my home theater, and as part of my active design, I had them initially. I was trying to play them down to 500 because I was thinking, oh, the horn's big enough; they'll load down that far. But man, the
Yeah,
distortion
well,
at very low
oh,
volumes, it
yeah,
was
they'll,
fine.
yeah, honk like a
But
goose, bark like a dog. Yeah, it's no, no, no.
yeah,
That's not.
yeah, yeah. So I quickly wound up. I think they're closer to like 650 or so now, but with a really steep slope on them too. I think they're
Yeah,
48
that'll
dB
help a
running off a
great
mini
deal.
DSP. Yeah,
And then the horn is probably the old style with the long exponential throat.
yeah. I want to say, is it biradial? I can't even remember now which one it
Well, if
is.
it's a biradial, that was the start of doing things better.
Yeah, I think it's the 8330A. Is that the side speaker or the horn? I can't remember now, but I think
I
it's a
don't know.
bi-radial horn. It's been 5 or 6 years since I put that kit together, and I've already forgotten what it was. And I can't bring
Okay.
myself to upgrade my home theater because I'm stuck in that nostalgia loop. Like, these are the speakers that I literally listened to when I went and watched movies. I mean, you can't beat that, right? But then at the same
Right.
time, I'm thinking, all right, it's time for something else. And the crazy thing is those horns are so sensitive. They're like at the compression driver with the horn is at around like 118 dB at 1 watt. I mean, it's
Yep.
crazy. So any
Yep.
noise in that system, all I hear is shh, and it drives me insane. And I still haven't padded them yet. I know I need to, but I'm just
Oh, you
lazy, I
haven't
guess.
patted them? Yeah, you wanna.
No, I padded them with the DSP. I brought the level down, but I
No,
haven't
no,
put
no, no,
like
no.
a
You just need a plain old resistor pad.
yeah, right. So
An
I
L
know
pad,
doing that
maybe
will
10,
help.
10 dB worth of attenuation.
Yeah,
Just keep the
I'm lazy.
parallel resistor real small, like 2 ohms or something,
hmm
and adjust the series resistor to get sort of 10 dB of attenuation. And
Yeah.
yeah, that'll shut that noise up because, yeah, no amp on the planet stands a chance for
Right. Oh
residual
yeah.
noise. Yeah, too much.
Right. And especially because it's in a home theater application where I'm about 12 feet away. And 12 feet away for a speaker like that is basically in the near field. I mean, as far as noise level goes, it's basically like you're in the near field. Because
Yeah,
these are theater speakers that are meant to be listened to from 30 feet or more away. Uh,
yeah.
but
No,
but it's
yeah,
cool.
just use just a 2 resistor pad, and then you just, basically you'll run the amplifier harder, but so what? It
Yeah.
doesn't
Oh,
care. You're still, of
that
course, you're
amplifier's
still
got
going to be at
plenty.
108.
Yeah.
It's still going
Right.
to be louder than
Yeah.
everything else in the room by a bunch. So
Well,
it's
and
not
I'm
like
and I'm using
everything.
crown amps too with like 500 watts per channel at 8 ohms. So there's no shortage of power on that system. It's pretty ridiculous, but it's fun. You know, I don't listen to it too loud, but that's the thing I love about it is so freaking dynamic. I mean, anything
Yeah,
that happens in a movie, it's like, oh god, you know,
you
for
want to
better
really
or
make a
worse.
change, get yourself a couple of tube amps.
Really.
Yeah,
Well, you may talk
put
me
put
into
like a
some more
10
money.
dB pad on it and get some Quicksilver tube amps, and you won't believe it's the same speaker.
I'll have to look into that.
The
I probably don't
difference
have the
is
money, but
the difference is amazing. It's just absolutely amazing. Well, some of the tube amps aren't all that expensive these days.
mhm,
Um, it will, and you need, I don't know, 30, 50 watts will do the job. They don't have to be huge.
right.
Um, but there's something about a tube with a compression driver. The blend is amazing, and most of the harshness goes away, but the speed and the detail is still there.
That's interesting. So I'll as a measurement person, I will be honest with you. I've heard that said, and I'm like, man, I don't know if I believe that, but I've never given it a shot. The closest I've come is I borrowed some tube amps for some clip speakers, but nothing I could do with those clip speakers. I'm not gonna say anything mean. They weren't the speakers for me. I'll just put it that way. So,
Yeah. Okay. Um,
yeah.
well, in this case, you're biamping, so you're only talking about substituting an amp on one transducer.
Hmm.
You have to get the gain right again because it'll have a different gain structure in your.
Yeah. That's
But
not a big deal.
it's the difference is not subtle, and it's the way the tubes operate. They just do things different in a different manner than solid state does.
Yeah.
We don't have a
Um,
great handle on all those measurements. That's all.
Well, I think that's what's fun about it, though, is the pursuit to try to understand more, right? You know,
Yeah.
like if we just said, I
Mhm.
know everything. I mean, even speakers, even with all the frequency response data, and we can kind of get an idea of the sound radiation into a room and measuring using the moving mic method compared to the estimation, it always lines up pretty well in my case. But
Yes.
even knowing all of that, there's still those things that you can't, like when people ask me, should I get X or Z speaker? I always say, listen to both because I may like both of them. I may choose one for a different reason than you would, but whether it be
Yeah.
uh, dispersion characteristics or the timbre of the speaker or just the looks. There's a number of things about speakers that are different. But again, that's what makes it fun, and that's what can make it unique.
Yes, sir.
Um. So here's a question I've got for you: constant. Talk about directivity, and this is I may be making up terms, so feel free to correct me. I've always assumed constant directivity and controlled directivity to be kind of two different things. Although I guess constant would be under the umbrella of controlled, and what I mean is constant would be just like a flat line in directivity, whereas
Yes.
controlled could be any line, but as long as it's a line, it's linear. Um,
Not even that, but yes, a constant
but
directivity means that the speaker is supposed to have the same angular coverage from DC to light, which no
okay,
speaker does, but they make an attempt above some point.
right,
Um, Control directivity, we actually JBL came up with that term for the original Everest.
okay, that's cool.
Um,
I didn't know that.
because the original Everest used a 4660 horn that Don Keel designed for a very peculiar application. It was intended to be a single speaker, in effect, over the presenter on a stage. It would be up above them,
Hmm.
and it projected a very non-linear pattern. But if you walk the room around the square perimeter of the room and anywhere in the middle, you would get the same SPL at all frequencies.
That's
So
crazy.
how does one do that, you might
Oh,
ask? Well, what it does is the directivity it's a controlled directivity, and at the horn was designed as a bunch of different cross sections, and in each of these, and then spliced together, and
hmm.
each of these cross sections would have a different pattern. So at one end of this big horn, the pattern was very, very narrow, and at the other end of the horn, the pattern was very, very wide. And since the compression driver is putting out constant power, In the wide area, the on-axis SPL is reduced.
Hmm.
At the narrow area, the SPL is much greater, and it was greater to the degree that it made up for the square the distance fall off.
Hmm. Okay.
So what basically what this thing does is as you move across its surface, the sound gets louder. So if you put it away from you, you have to be in the far field for it to work properly. You can literally walk across the room, getting further from the horn, and the sound stays the same loudness. So
Yeah.
we
I'm
took
not.
this
That's great.
thing and put it on its side in the original Everest. And what happened was when you were at the back of the room on the wide side of the thing, it would be so loud. And as you moved to the right, getting further from the speaker, you'd get to where the speaker was louder and it would stay the same loudness. Now you take another one of these things and do it on the other side of the room in stereo, and you had the converse. So you could move back and forth and the level would stay the same.
Wow. Yeah.
And it produced very, very interesting imaging properties. Now you can't correct for the time delay. So,
Okay.
there would still be that aspect, but
Hmm.
the thing had a giant sweet spot, and you could be sitting way the hell off axis and still get a pretty good center image. And
That's crazy.
then we had a big 15-inch loudspeaker, and it was put at an angle to make use of the directivity of that woofer, so it would be louder pointing across the room, and then we were off axis as you came closer to it. So it sort of kind of worked a little bit
Hmm.
down into the woofer range as well. Um, and it was really slick.
Yeah.
And
That's
that's where we came up with the term control directivity, because we wanted it to be what it needed to be. It's not random. It's precise and it's controlled, but it's not constant.
yeah. Okay. Well, that's I wasn't aware. Obviously I've heard of Don Keel. I was thinking you were going to say he has some kind of array of speakers inside this horn or something. Like a because I know he came up with the CBT, the
Well,
constant beam width transducer setup.
it's sort of like that. It's a band. It was a band.
Right.
I forget six. I designed a couple of these horns subsequently myself, and I just designed. I knew what the mouth was going to be, and I
Hmm.
designed the insides to have a pattern that's this by that, and then a
Okay.
pattern that by this by that, and then you just kind of splice them together and smooth the curve. So it's kind of like having different little transducers, but it was all powered off of a single driver, and we angled the driver. The driver doesn't face forward. The driver faced kind of
Mm-mm. Mm-mm.
30 degrees, 40 degrees, something like that, so that we didn't have to do everything with the sidewalls. Um, but
Yeah.
the technology does work. And that in fact is what's in these ceiling speakers I talked to you about. It's one of those kind of horns that when you're right under it, it's soft, and as you get further away from it, it gets louder.
Yeah.
So
That's
that
pretty neat.
well, the speaker's louder, but you're further away, so it ends up being more or less constant level.
Right. Yeah. That's pretty cool stuff. Okay.
Yeah, it is. That was really fun.
Well, I
That took a
remember.
while for everybody to get their little brains around.
Yeah, no, I was going to say I remember when I first read about the CBT, and then he was doing I guess I refer to it as more like an analog shading, where it was actually the baffle itself was curved, right?
Yeah, that's pretty
Um,
cool too.
I remember reading about that and because there was all sorts, and there probably still is stuff about that design from briefings and things like that that I suppose he had given, but just being
Mhm.
like, oh my gosh, to me that's really cool stuff because that's thinking outside of the box, really, you know.
Yeah, he
It's
made a few prototypes of those. They were pretty slick. Unfortunately, sadly for me, to work right, they need to be little drivers, and you just
yeah,
even if you have a billion of them, it just never could get the dynamics that I liked. But the pattern and all that stuff was amazing.
It was crazy. Yeah, they show. I mean, you could stand up, you could sit down, you could move wherever you
You
want,
can
and it
move
was pretty much the
anywhere.
same
Yeah.
SPL anywhere
The
you
other
went.
issue is that they were producing pretty much 180 degrees both left and right. So the demand on the driver is really, really high. You're trying to fill a big volume.
Right.
So, and if you go with a larger driver, then the directivity of that driver is such that it doesn't meet the conditions all the way up to high frequencies. And then
Right.
if you use little two ways everywhere, now you've got a crossover and phasing, and two things need to be in the same place at the same time, and they can't physically be there, and
Yeah. Yeah.
it falls apart again. But
Yeah.
it is very slick.
Well, so the coverage pattern is kind of a question that I find interesting. Is how do you define or decide what the ideal radiation pattern is for a speaker? As in, a horizontal plane, do you want omni or do you want 70 degrees, basically like plus or minus 35? I mean, how do you go in and define that? And I don't know if
That
there's an easy
there's a
answer for that.
major difference of opinion on that. The Sean and Floyd guys are going to say you want 180 degrees. You
Hmm.
want it uniform everywhere.
Right.
But they don't believe in or feel much about dynamics. Um,
Right.
so me as a transducer guy, I go, well, dynamics are more important to me, so I'm going to cheat. I'm going to cheat on the pattern.
Hmm.
Having the pattern be at least uniform without discontinuities in it. It can slope downhill perhaps, but
Right.
if you have a discontinuity anywhere, you can hear it. It sounds it sticks out like a sore thumb.
Yeah.
So whether it's constant directivity or a tilde directivity is also kind of negotiable.
Okay.
But loading the driver too severely is going to start to take away from your dynamic behavior.
Yeah.
My systems here, I set at 120.
Okay. And
Um,
so is that horizontal and vertical, or is that horizontal?
yeah, well, yes, it's horizontal and vertical, but
Okay.
there are going to be some foo bars in the vertical. You can't, if the drivers are
Yeah.
off,
Especially with the drivers being that
vertically
large.
from each other, you're going to have some issues because I'm
Yeah.
not
Right.
crossed over low enough. And if I cross over low enough, then
Your
I
dynamic
lose
range, right?
my sensitivity or dynamics again because
Yeah.
you're
Well,
beating the hell out of the driver below where it can go.
yeah, and that's just it's all about the trade-offs at that point, Like
That's right.
when I review these speakers, and the reason I was asking about the coverage pattern, I was curious what your thoughts were. I've noticed that I tend to prefer speakers that are wider. Um, and then when speakers get below like plus or minus 50, I don't enjoy them as much because I prefer more room interaction, personally speaking.
Hmm.
But depending on somebody else's room or just their general preference, they may prefer something that's more narrow than I do, and that's okay because I think a lot of people too, when they see that I'm doing measurements, maybe they misunderstand that I'm trying to say that this is what it's got to be, and I'm really adamant that I think that's the one area that I don't think there's a definition for preference. Everybody seems to kind of like a wider speaker or a more narrow speaker, and then it's going to kind of depend on your room. Are you going to live in a glass room or do you live in a padded room, right? So
And that's
I
true
think those
too.
factors come into
The
play.
deader your room, the more you can get away with a narrower bandwidth speaker or narrower directivity speaker
Yeah,
because it's
right.
not going to.
It does nothing
You can
changes off
shoot
the
it at the
side.
walls; it ain't going to come back anyway. So
Exactly right, which is kind of almost counterintuitive because you would think if you have a more dead room, then it wouldn't matter if you had a really wide speaker. But the point is that it doesn't matter because nothing's reflecting off the wall anyway. So it
yeah, so
doesn't matter
why
if
not
it's
send the
super
energy
narrow
where
or
it's going to send it where you want it, not
right.
throw it away.
Right. Yeah, exactly. But then there's people kind of like me where I like some wall bounce. I like that. Oh wow, the sound stage is way out here, but if it were an anechoic chamber, it would be probably right there in front of me. So, but I think that's okay to have a preference and to enjoy something that somebody else maybe doesn't enjoy.
Yeah, personally I shoot at 90 to 120. So
Okay.
that would be whatever 45 to 60.
Yeah. I think to me
This
that would
kind
probably
of
be that.
number. If it's much wider than that, um, I think personally you're wasting energy.
Okay.
And if it's much narrower than that, it's you start to lose some cool stuff that can happen.
Right. And that's where I fall in the realm of my preference is I think tonally most speakers are okay. You know, and not, some of them are great, some of them are bad, but most of them are at least okay.
Yes.
And but it just I love the mind trickery when images do things in the soundstage or they're placed somewhere else that maybe I'm not used to them being. As long as they're stable, I don't want images like I don't want a horn sounding like it's here, but also over here because there's a
Yeah.
discontinuity in the horizontal. That
Hmm.
drives me nuts. But I like the cool things that happen in soundstage. I just gravitate toward that. You know, so if all things are equal, I want that. But some people
Yeah.
don't like that. Some people like super precise focus and things like that. So okay,
Well,
it's
you can
cool, man.
kind of get both. If
Yeah,
if things are if things are good enough, you should be able to rationalize this, down to maybe an orange or something.
yeah,
Not a very you can get down to a pretty tight and yet still have depth and width.
yeah,
But it requires it's everything in the chain. It isn't just the loudspeaker. It's
yeah.
the enclosure itself. It's the electronics, and I still don't know what makes depth in electronics. Some have it and some are flat, and it drives me nuts. But
Right.
it's different.
So I can't speak for electronics, but I can just tell you that my personal experience with depth is good coaxial drivers, like concentric drivers, always seem to
Yeah.
have a really deep soundstage. Kef and Genelec do a really good job, in my opinion, of really good concentric drivers. And I don't know if so. There's two things that are going on about a good concentric driver. Is number one, the polar pattern is pretty much the same sideways and
Yes.
vertically.
Yes.
But then number
Absolutely.
two is they're already basically time aligned. I mean, within a fraction of a millisecond. Whereas most loudspeakers
They
maybe
can
not
be
be that
because
way.
the woofer's way behind itself physically because
Hmm.
it's got a lot of because it has limited bandwidth, and the compression driver is actually now is right where the diaphragm is. It doesn't move, and it's
Right.
placed now way behind the woofer in more or less the right spot.
Right.
So yeah, you can get those coaxes pretty nicely time aligned. Um, you can do that with a horn on a baffle if you design the horn length correctly. If you design the horn length to go with the specific woofer, but now
Hmm.
you don't have the coaxial aspects. So in the vertical plane, you're going to suffer uh, dispersion wise
Yeah.
at the
And to
crossover.
me, that's the question. Those are the two distinct differences from a coaxial versus a standard. And so which one of those, or is it either of those, that are driving that sense of depth that I feel like I hear? Or is it just my total imagination because I've been conditioned to think that coaxials are better in
I
that
don't
regard?
think so. I think it's probably you're probably hearing the good time alignment, which you could fix with a digital system, or
Yeah.
you can fix it if you design the enclosure such that the woofer and the compression driver horn combination are in the right
Physically aligned.
respective spots.
Right.
Um,
It's interesting
yeah,
stuff though. I've always wondered
but
like what happens if you take a concentric driver and then you just put a box of, like put something above and below it and squash the vertical. What happens to your perception of that speaker? Does it change because now the polar isn't the same horizontally and vertically? Or does it change? It's just stuff like that that keeps me awake at night. I'll put it that way.
yeah, you would end up with a narrower vertical pattern. The speaker as a whole would get louder, and it would be more dynamic because you're now not throwing power everywhere.
Yeah.
The biggest difficulty with coaxes is the compression driver is messed up by the cone,
You're
both
talking
from a
about
Doppler standpoint
yeah, right, right.
and from a so generally they don't come right out of the there's some patents and there's ways around them, but uh, the coax throat, if it comes out right at the cone neck, I think Kef has a patent on that one.
Yeah, I'm sure that they do.
Um, that's ideal. You do modulate it with the cone walls, but if the horn exit sticks forward of that junction slightly, then you've got all kinds of crap that goes on
Right.
in there, and those
Well,
those aren't good things, but
that's
are
like
they
the
more or less worse than the, other things?
yeah. I was just going to say that's like the car audio coaxials where they've got the tweeter mounted like an inch or two in front of the midwoofer, and it's not really a time aligned coaxial. It's just a
No.
they're kind of in the same space together, like, but that's about it.
Yeah, but those are actually very bad from a time alignment standpoint because the tweeter's 3, 4, 5 inches off
Yeah.
of alignment.
Yeah.
But they do that for compactness, that's
Right.
why
Yeah.
they have
Absolutely.
everything in one.
Right.
And
Yeah.
somebody definitely has a patent on sticking the tweeter on top of the pole piece,
Yeah. Yeah. I
which,
wonder. I would think that would be Kef, but I don't keep up with patents. I'm not smart enough to read that stuff. There's a bunch of schematics and lawyers talking there, and I'm just like, okay, sure, whatever they say, I'll
well,
believe them.
a good third of the audio patents are bogus anyways.
I
Um,
think a lot of them are written by marketing. Sometimes I think the engineers are like, I get one paragraph, and then maybe the marketers get like the rest of them.
well, the examiners don't go back far enough. They just don't look.
Hmm.
If you get a book like Olson wrote a book in the 20s. Pretty much everything under the sun is described in that book. And I'd say at least 25% of today's acoustic patents could be thrown out if the examiner had just read that book because he discusses whatever the hell the guy's trying to patent.
Yeah,
But they just don't go back that far. And there's a lot of prior art things that happened and then went away that also aren't included in the studies, which is sad. Because a lot of patents that are getting issued just aren't valid,
yeah,
but it's kind of how it is. So I kind of don't bother. In some respects, you're better off kind of concealing it and not getting a patent on it because then people don't know exactly what it is.
that's true. Yeah, well, and we were talking about Kef. I'm really surprised at how forthcoming that Kef is. Sometimes they just released a new speaker today and they have released a white paper for it. So Kef always does that. They're one of the few companies I know that still does that actively. And I'm almost surprised that they release so much information. I'm just like, maybe you guys might want to hold stuff a little bit closer to chest, but I'm sure there's a lot more that
Well,
they
they
know that
either
they're
they
not letting
either had
out.
it locked up with a patent or it's prior art, um, and they're not worried.
Yeah.
A lot of
Yeah.
what we did at JBL was so damn expensive, we never had to worry about anybody else copying it.
Well,
Some of the tolerances in our compression drivers and things of that sort were just insane. Um, and manufacturing hated us. But it turns out if you made the gaps larger so that there would be more room, these side effects occurred, which impacted the frequency response, and there's no way around it. So other companies that use bigger gaps in their compression drivers had response problems that we don't have.
oh, okay.
But we have yield issues trying to get these things absolutely perfect every time.
Yeah. Yeah, I
Um,
can imagine.
so that was often the case. You just no one's going to do that. No one's going to be stupid enough to
And then
do
you'd be
it.
like,
We make it
except for
ourselves
us.
in our own little machine shop, and
Yeah.
if you want to do it, good luck.
Yeah. Right. Right. Um, so kind of getting off of that topic, maybe I'm curious, have you ever listened to open baffle setups are kind of popular with a segment of the community? I've heard a couple, not necessarily been more impressed with those designs than I am with other conventional type speakers, but I was specifically asked to ask you if you've heard open baffle setups and if you have, what are your thoughts of those?
One of my favorite loudspeakers from a I'm glad you did this kind of standpoint was something that Carver did a long time ago. It had six 12-inch um, transducers on an open back baffle, and a big ribbon next to it. And what he did wisely, we'll get into the unwise part, is he used itty bitty little magnets on his big 12-inch woofers. So the basic Q of the driver was 2, which means it had a 6 dB bump in the bottom
Yeah,
end.
I mean, it's a really sharp peak right there, right?
Yeah. So then he put it on a baffle of a particular width, and you get a 6 dB roll off from an open baffle. So he was flat to 35 hertz.
Wow, that's crazy.
So he and no box.
Right.
Um, it was really clever. It measured quite well, and it sounded okay. Being that he was out after cheap, um, he didn't do it what would have been the right way. The right way would have been to use huge magnets and huge amounts of metal. Um, you can still set the Q at 2 if you want, but now
Hmm.
you wouldn't have heat issues because he used these little itty bitty 1-inch voice coils or 1.5-inch voice coils or something like that. Couldn't
Right.
handle any power, so the thing would overheat and squash dynamically instantly.
Right.
Um, but the technique was very clever. Um, he just used the transducer to have the inverse of what the roll off. I do kind of like the sound of open back.
Yeah.
Um, you've got
Well,
issues with placement in rooms.
right.
Just with I like electrostatics too, with the caveat that they've got all kinds of issues, but you can get some marvelous sound under certain conditions with electrostatics, um, and other kinds of planers.
Hmm.
But there's just trade-offs.
Right. Well, I think the biggest thing for me was it just sounded more spacious, but I don't know if that was me, you know?
No,
Um,
they do. They are because they're radiating both directions, so you're
right,
getting a bunch
exactly.
of.
You're getting that dipole
If you were
formation.
to put them outside or you put them in a wall, the old infinite baffle loudspeaker,
Right.
that wouldn't be the case because the back wave would go nowhere and you'd just lose efficiency and you wouldn't get anything.
Hmm.
In the case of the woofer, you might be slightly ahead because trapping all that volume, that back wave in a volume, and you know walls vibrating and the back load on the woofer and all that can't be good.
Yeah.
So from a sonic standpoint, it might just if you had a system in a wall and the outside, it went to the outside and then your part's in the room,
Right.
the sound might be very nice, but it's driving with the brakes on, kind of. You got your foot on
Yeah.
the gas and your foot on the brake at the same time.
Yeah. Yeah. Well, so it's funny you mentioned the in wall thing because I've actually, I mentioned earlier about how I've thought about changing my home theater setup. And the reason I thought about changing it is to go with in wall speakers. But obviously there's reasons that I don't want to do that for, but it does give you plenty of room. So I built a false wall to put my JBLs behind and have an acoustically transparent screen. And it's awesome, but it just consumes so much space of the upstairs
Yes.
room that it would be nice not to have that anymore. But I know as soon as I put in wall speakers in, I'm going to kick myself, for not keeping what I had. But there's that itch of wanting to play around with new stuff, try new things.
Yeah, you'll suffer dynamically. It's tough. It's
Yeah.
really.
Well, I mean, coming from a 15-inch, a 2035 HPL, I think we're the woofers. 4 cubic foot enclosures tuned to 50, mid 50s or 60s.
Mhm.
So I mean, they rock, and that system gets dumb loud. But again, I took 3 feet off of my back wall, and it's of no use whatsoever. And then with a
Yep.
kid and dogs and stuff like that, be nice to
Yeah.
have some of that back. But who knows? Maybe we'll see. I might just be too lazy or too busy to ever change anything anyway. But no, I was curious about the open baffle stuff, because I have, like I mentioned, I've heard a couple, and I thought they did some things that were great, but in an overall package, I don't necessarily think that they're better than some of the other speakers that I've heard that are standard enclosure type designs because there's always some kind of trade offs. Now, having said that, cardioid designs, I've been able to demo some active powered DSP controlled cardioid designs that were fantastic. And the cool thing is you could put those right next to the rear wall and load the subwoofers on the back off the rear wall. So then you really did have, for one of the speakers, it was 20 hertz. I mean, I was plus 13 or 15 dB at 20 hertz in room, so I could basically just knock off the bass on the low end if I wanted to. Um,
They're
but
highly inefficient is all. If
right,
you have the amp power and sufficient transducers to get your dynamics back, but you're using the 2 woofers to cancel most of the energy,
right, right.
in order to get the whatever 90-degree pattern or something that you want out of it.
Hmm.
Um, it's just another side effect.
Another compromise,
Yeah,
right?
in theory, it makes really good sense.
Yeah. Well, yeah, because number one, it takes up less room, less space in the room. It's almost like an oxymoron. Anyway, um, but also they sound fantastic. I don't know why. I think I have an idea why, but they sound fantastic. But again, that's just another one of those. Like we talk about, this speaker is great. Well, if it's so great, why doesn't everybody buy it? Well, because everybody likes doing different things, right?
Mhm.
And there's always room for Jello, as they say. But if I had my choice, I would have 5 or 6 different rooms. I know it's heresy, but the Bose 901, the most inaccurate speaker I think I've ever listened to, but
The
crazy.
original?
Well, it was a Series 5, so which I think they made up to 6, but that was a.
The original was a kick in the butt, and, I really like them.
I just thought they were cool. Just they did some really
They
neat things.
they did some really neat things. Their biggest problem, well, they were very inefficient,
Mm,
and they used really crap electronics in their little EQ box, which
yeah.
degraded the sound immensely. If that were a nice piece of electronics, um, they would have sounded a lot better. Then they went I think the 2nd generation, they put a port in it
Okay.
because they wanted to, because the first box was sealed, and you had to really ram on those 9.5s to get, bass, because they had the EQ, and I forget, it was something like 20 dB of 15 to 20 dB of bass boost at 30 hertz
Yeah.
is
No.
what that
That's
box produced.
yeah.
And you needed massive amplifiers, and these things came out just before amps were getting. You could get big amps. A 100-watt amp wouldn't do it. You really needed like a 500-watt amp to go with the original 901s.
Mm.
So if you did all that stuff correctly and redid the box for proper sonics, the little EQ box, I still think they're cool as shit. I really do.
Yeah, no, I mean, I agree. I when I did the review for them, I basically said they're not accurate, but they do some really cool things, and I get it. I get why people like these speakers, and I also get why people don't like these speakers. You know?
I've never measured a set. They didn't measure very well.
No,
See, they
the best.
could.
No,
There's
well, I
no reason
tried.
they couldn't measure beautifully.
Right, yeah, and they came with the box. I tried all sorts of the treble settings, the bass settings. I tried everything in between to try to get them, but they were all over the map. But they were really fun. So there's
Yeah.
that. I think if I were rich, I would have a room dedicated to some Bose 901s, just every once in a while to go in and be like, all right, this is different. Let me go play around with these.
I agree, and they use little cheap transducers. I
Yeah,
mean, yeah, you use some good transducers uh, in those. That could be really, really. It wouldn't be as cheap, but that could be really nice.
yeah. I would
Uh,
like to see somebody like a DIYer take a modern day stab at something like that. Know what we know now and try to linearize them a little bit more. It's not gonna be perfect, but it would still be interesting. I think you could do, or even just if you could EQ them a little bit, that might help a lot.
it would help a great deal. Yeah.
Yeah. Well, there is a company who sells EQ mini DSPs, but they have them preloaded with the Bose 901, whichever series you want to buy. They have them preloaded
Oh,
with those
cool!
curves
That's so
into them.
funny.
Yeah, yeah, and I'm sure they make pretty good money, and the prices for them are pretty reasonable. I can't remember the name of the company now, but if anybody's watching, they can just Google that. But yeah, it's pretty neat. I thought about reaching out
Well,
to them, but I had to
you
send them
could
back.
program a mini DSP to do it. I mean, you'd have to
Right.
make some, but
Well,
you get back in the room, do the moving mic.
Yeah, yeah.
um, measurement and process a little stuff in REW, and you come up with an EQ curve that would probably make them sound pretty decent.
Pretty dang decent. Yeah, I actually threw a mini DSP at it in the loop just to kind of smooth it out, and I was like, oh, that's pretty cool, And it did it without getting rid of, because you EQ doesn't affect the directivity, so all the
No,
same
and
spatial
the
stuff that
fact that
it
it's
did.
squirting stuff everywhere here, and it's got just the two
Yeah,
little speakers in the front.
yeah,
I might add. I think if I were doing it, I'd probably add a front tweeter.
right, yeah, yeah,
So the front one would be like a two-way, so you could get some real highs out of the front. Because I don't care how much you goose those fives, you're not going to be able to get it. But you don't
well,
need it in that much in the sound power, and then you could goose the living daylights out of the
oh,
other eight.
yeah, absolutely,
And
yeah, because
it would
I
be
think, yeah, it was a 5 inch or so full range on the front, and I think 5 inches on the back, or eight
that's
six,
right.
something
Yeah.
like that. Yeah, I think they're
Yeah,
probably all the
no, it
same
had
driver.
nine altogether. They were connected in series parallel, and all were run the same.
Yeah,
Said I would have the front one be somewhat different,
right,
and just
yeah.
have the other 8 slam out the back, and you could EQ them to
And
get
just enjoy. Yeah,
respectable,
the
power
sound
response.
stage was just huge. I mean, stuff
Yeah,
was all over the place, not in a good way, but it was still kind of fun and cool. I was just like,
yeah.
I've never heard a speaker that does this, and I get why people don't like it, but again, I enjoyed it for what it was worth.
Well, with modern DSP, I think it could sound pretty slick.
Yeah. Oh, for sure. Well, I don't know what time you're on, but I've got to get off here in about 10 minutes or so to go pick up my daughter. Um,
Alrighty.
but I don't know. Let me see here. If you've got a minute, let me make sure that everybody.
Yeah,
It's
I'm
actually
good at
funny because we somehow managed to touch on all the topics that everybody asked about, even though I didn't ask you. Somebody actually asked about fear versus IIR crossovers, and you talked about that. So that's cool.
Okay. Well, if you
Yeah.
have any follow-up or anything quick, let me know. Other than that, go get your daughter.
Yeah, man. No, I'm good actually. So let me know if you're available in the future. What I'll do is I'll ask anybody's watching this in the comments. Please leave a thank you to Greg for joining. Oh, before I go, allow me a moment to do probably the corniest audiophile joke you'll ever hear at your expense, if you don't mind.
Okay.
Okay.
There's been a comic
Has,
book of me in Japan going on the toilet, so don't you couldn't
okay.
possibly
Well,
catch
it's
it.
not going to be toilet humor, and you may have heard this. Stop me if you have. But is your last name pronounced Timbers?
No, it is not. I've never heard that. I have
So
never
you've never
shiver I
heard
get
that?
shiver me all the time,
Shiver me timbers. That's a good one too.
but I have never heard timbres. Never.
That's funny because well, I mean, it's not spelled the same way as the real timber,
I
but
know,
I
but
mean
it's
the tonality timber.
close,
But
close enough for
for,
government work.
yeah, exactly. Well, I
I
never
like
knew that
that.
it was pronounced timber. I always pronounced the word timber because that's kind of how it looks. And then I heard people saying timber, and I was like, yeah, they're saying it wrong. And then I actually went and looked it up, and I said, oh, that's actually how it's pronounced. So yeah, I thought I would drop that terrible, lame dad joke on you. I was curious if you'd heard
No
it
problem.
before.
I can live with it.
All right. Well, cool, man. Well, again, I'll ask everybody if you don't mind, please leave a comment below. If you have any questions for Greg, let me know, and maybe we can schedule to
Yeah,
do this again
and
sometime in the future.
this was, I mean, totally painless for me.
Yeah,
We can do
non-invasive.
another session sometime if you gather some decent topics, because
Yeah, man. I would
I have
love to.
no problem
Yeah,
talking, and it's worth
yeah,
what it costs you. I mean,
yeah. Exactly. Didn't cost
yeah,
anybody a dime, but no, I appreciate getting to pick your brain and to talk to you. I mean, you've done some incredible designs, and I do appreciate your time joining me and all that stuff. And again, like I said, I would maybe we'll pick up back up on this again in the future.
all righty. Well, it was my pleasure. This was a lot of fun.
Yeah, man. All right. Well, have a good afternoon, I guess, because you're on California time. So enjoy
Yeah,
it.
I'm 4:06. Time for the dog walk. Oops, he heard
Oh
that.
yeah,
So
yeah.
now
All right.
I'm stuck.
Now you're in trouble. That's right. Well, have a good
Yeah.
one, man. All right.
All righty,
Bye.
you too. I don't even know how to close this thing off.
You'll figure it out. You got this.
All righty. Bye.
All right. Bye.